Welcome to the radar system course. Today we continue the discussion on the CW radar, that is a continuous wave radar. And we have seen earlier a block diagram of a CW radar. So in that case, we have the transmitter, separate transmitter for the CW for the continuous wave generation. Generally, we supposed to use the magnetron for the same. It is just like a local oscillator. It just send transmitting signal. So people are saying for the local oscillator somewhere it is about FO here, but we supposed to consider that signal is transmitted toward the object. This one is about object or a target, we say. And when it reaches to the target, then it will reflect back, or echo signal will come from this. Okay, so then this one is about a echo signal, we say. And this echo signal has a frequency of whatever the transmitting frequency signal, plus or minus AFD here. That FD is nothing but a Doppler frequency. Now we consider that a signal transmitting signal, then the receiving signal. So at the mixer, we are getting a both the signal, that is about a transmitter and a receiver. So generally, what happen? So we supposed to use a junction here. So it allows only the receiving signal, that is echo signal at the mixer. But in the CW radar, it this mixer contain whatever the transmitting signal as well as what will be the echo signal here. So means we have a detector here. So detector detect whichever the difference in the frequency. Okay, so that will be detected by the detector. So that's why we say here there is a Doppler filter. Okay, so that's why we can say that there will be a Doppler filter. So it just accept the whichever the frequency shift there, and then we have the indicator. Then we have the indicator. Okay, now this one is about a indicator. Now we transmit the signal towards the object or a target. We say target here, and then when that signal reach to the target, according to the motion of this particular object toward the radar or away from the radar, there will be a change in the frequency signal, that will be ft plus or minus ft. Okay, if it is nearer, then there will be plus sign. Okay, so likewise we can supposed to find out so what will be the change in the frequency there. Okay, so now at the receiver. Okay, at the receiver we are getting a two signal. One signal is about what we have, AFT plus or minus FD here, and here we are getting the signal, that is only the whatever the signal we are transmitting, or we say that a oscillator frequency signal. Now we will see that what will be the difference in the frequency, that is about a Doppler frequency. Okay, so we can say that when a signal transmitted by a transmitter to the target here, and it has a frequency of oscillation here, we say that AF is a transmitted frequency of T here. When it reaches to the target, then some portion of the signal frequency that will be reflected back, or we can say that when it reaches to this one object, then that object will, that because when it bombarded on this object, the signal will be scattered. Now that some of the portion of that scattered signal will reach to the a receiver here. Okay, so we have a detector here, and that portion, okay, whichever the scattered signal, some of the portion of the received signal, that scattered signal, that is nothing but a echo that will reach to the antenna here. That is about the receiving antenna. Now, based on the motion of this target, okay, so we say that it has that object or a target has some relative velocity, and that Relative velocity means what? We have the motion of the this object toward the radar or away from the radar. Then because of this, whichever the signal received at this receiver, that will be shifted. Okay, the receiver signal received at this place, that will be a shifted here. So shifted means what? We are getting a signal frequency. We say that transmitted frequency signal. But echo signal consists of what? A ft plus or minus fd. Okay, ft plus or minus fd means we are getting ft plus or minus fd. Okay, if you are not able to see it clearly here, I'll rewrite again here at this place here. So we are getting the signal that will be ft plus or minus fd. Okay, plus or minus fd. And that plus sign indicates that the object or this target is nearer to the radar here. Minus sign means what? It goes away from the radar. Means there is a change in the frequency. If the frequency is increases, means ft plus fd, frequency is increases there. Okay, so then what happen? There will be the distance between the object and a receiver radar, that will be a closer or that will be close to each other there. If it is large, the frequency is large, then the distance between the target and the radar will be away from it. Okay, large, it will be large. It will be closer or large. So based on that a signal here, we are receiving whether it is a plus or minus sign there. So according to that, we are getting the signal that we say that whether the target is away from this radar or it will nearer to the radar there. If it is plus, nearer to the radar. If it is minus, away from the radar. Okay, means here the distance between the object and transmitter, if it is a closer, then it will be ft plus fd. If it is away from this, so then we say that ft minus fd. And then this is about the received signal, or we can say that echo signal. Now here we have a transmitter. So transmitter transmitting the signal frequency, we say it is a ft now. But that ft signal is less than whatever the signal transmitted by this transmitter. Why it is less here? That level of the this ft, it will be very very low. So if that level of that ft is a large, then our detector will damage or our devices will damage. Because generally we are using a high signal, high power signal to be transmitted to the target. If the same high power signal, if it is received at the detector, so detector may get damaged. So that's why whichever the signal, okay, reached at this mixer from this transmitter, that level will be very very low here. Or we can say that in another way, this ft is nothing but the noise. Okay, ft is nothing but the noise portion of a transmitter. Okay, or we supposed to use a junction here at this particular place, so it will forward only a small portion or a very very small portion of the transmitted signal to the detector here, so that detector is able to differentiate this both the signal. Now we say that this one is about a detector. So generally what happened at the mixer, we supposed to send a local oscillator frequency signal as well as the whatever the receive. But right now we say that ft is nothing but your local oscillator frequency signal, and we supposed to get that a signal is what? Ft plus or minus fd here, or this one. Because we have a mixer will differentiating that what will be your ft or a fd here. We say that ft plus or minus fd. So generally it is about a minus sign is to be used, plus is not to be used. Ft minus ft get cancelled. We will get either here a plus fd or a minus fd. So we received at this a FD here, and that FD, that is nothing but a Doppler filter. Okay, that is given to the a Doppler filter. Or we can say that Doppler filter means what? That is a approximate echo signal frequency. Okay, band. That is okay. That is that's why we say it is about a filter. Only some portion of the signal is to be given to the a Doppler filter. So it is just like a act as a band pass filter, or you can say that a bit frequency amplifier here. So it will amplify the echo signal as well as it will filter out. So now what will be the lowest range and what will be the maximum range of this particular filter, that will define the property of your CW transmitter, that CW radar there. So we consider that this particular Doppler filter, that if supposed to be, this has a very low minimum signal. Okay, low FD. Okay, we can say that FD is very low. Okay, initial range. So in that case, what happens? So it will consist of a environmental reflected signal. So that's why we can say that a clutter. That's why we need to avoid those clutters. So that's why we need to increase that a minimum frequency signal. There is maximum one. Again, it will consist of some particular noise. So to avoid the noise, okay, to avoid the noise, we supposed to find out, or we supposed to define the range of this Doppler filter. Okay, so that only that particular frequency signal is to be passed through it. And this FD will indicate what? That will be the range of this object or a target from this radar. If so means within a particular range of this range, okay, so that radar is able to identify the object is present in their place, okay, in their particular region. So that's why FD is to be selected in such a way that, so that is, that will define or that will reflect the whether that object is present within that particular range or not. Okay, so that's why we're supposed to consider that a Doppler filter with a specific frequency band. And again, if you consider that a low frequency here, if you consider that a cutoff at a low frequency and cutoff at a high frequency, there will be a noise will introduce at the low frequency cutoff. Okay, that noise is called as a DC component noise. Okay, that DC component noise from the environment, or a supposed to be, we say it is about, there will be a stationary target or something else. So to avoid it, we consider that a lowest cutoff frequency as well as the highest cutoff frequency for this a Doppler here. Then after that, okay, the signal is reached to the indicator. Now here the role of the filter is what? To remove the noise whichever will come here, okay, toward this particular Doppler filter or a bit frequency amplifier. Okay, then that will be removed by this filter here. Okay, so then actual FD, okay, actual frequency signal, that will be, or echo signal, come from the target, that will be reached to the indicator. Now then, what are the various types of indicators supposed to be used in a CW radar? It's not a display device. Okay, it's just like a, we supposed to use that a frequency meter as the indicator, or a earphone, okay, as the indicator. So then, if we supposed to know that what will be the exact value of that Doppler frequency received at this CW radar, so then we need to define a frequency meter or a earphone for that particular EFT. So that's why we supposed to select a proper indicator, frequency meter, or a earphone. Okay, or some particular filter that will just propagate or that will just pass only that particular frequency band of a signal to the a device there. Okay, so this way we're supposed to use a indicator there. Now, in a CW radar, we say here a transmitter and a receiver. Okay, this is about a portion of the receiver, half of the portion. We're supposed to say that this one is about a receiver portion. Okay, this one is about your receiver portion, and above is nothing but a transmitter. This one is about your receiver. Okay, now this one is about a portion of a receiver. Now we supposed to use only a single antenna for both the transmitting as well as for the receiving. Then we need to use a isolator here, that is that will isolate the transmitter and receiver, and that will use to avoid damage of this receiver there. Okay, so there should be a separation. Okay, there may be a separation of a transmitter and receiver. It should be taken care. So we can use a circulator or a junction T here, and that will use only the transmitter as well as the receiver there. So T junction. Okay, so you people have seen the microwave T junction, that is to be used for the purpose of a isolation. So only at the time of a transmitter, okay, that device will transmit. At the receiver, only that junction will propose forward the signal to the detector. So only single antenna is sufficient. Okay, single antenna is sufficient for the transmitter as well as the receiver. So we can use the isolator there, or for this isolation, we supposed to use a different devices, such as a T, such as a circulator there, or we can use a separate transmitter or a separate receiver there. Okay, or we can say that separate transmitting antenna and a separate receiving antenna. These are the different ways there. Okay, so that will avoid the isolation between the transmitter and a receiver there. But what happened here in general, if supposed to be we are using same antenna for the transmitter as well as the receiver, then what will happen? Some portion of the signal from the transmitter may reach to the detector there. If supposed to be a transmitted signal will be large and that will reach to the detector, so then what will happen? That will damage the circuit here, receiver circuit. So we are supposed to consider that what signal supposed to come at the receiver, at the detector, that is to be a low value. Even if some noise is present at a transmitter, if that noise will reach to the detector or the mixer there at a receiver there, so then that noise will disturb this receiver operation, or that noise will damage the whatever the received signal, because as the indicator we supposed to use a earphone here, okay, or a frequency meter, so that will provide you or that will give us the false indication of the receiver. Okay, false indication of the a target there. So that's why we consider that the isolation, okay, properly here at the transmitter and a receiver. So mostly if we are using a long range CW radar, okay, long range CW radar, so in that case a power transmitted by this transmitter will be a very high. So in that case there may be a small leakage of a transmitted power, and that leakage of a transmitted power that may avoid or that may disturb this detector, or that may damage our receiver section. So that's why we supposed to use a isolation between this a transmitter and a receiver. So generally, if you consider that here we are transmitting the a continuous signal. Okay, we are transmitting the continuous signal. So frequency band for this continuous signal has some restriction there. Okay, so that's why that a Doppler filter we are supposed to use here, they have a restriction regarding the what will be the continuous signal frequency we have. So expected frequency signal we are supposed to receive it at this Doppler filter. There may be a change of the frequency because if there will be a continuous signal, then band required will be restricted there, and then we are supposed to demodulate at this particular end. Okay, demodulation is to be expressed at this particular end. In that case, they have some noise introduced at the case of a demodulation there. Okay, at the time at the receiver there. So echo signal we are getting, as well as we are getting some clutter signal. That clutter is nothing but a signal received from the nearby target or that environmental objects. So that when it reach that signal, when your the transmitted signal reach to that environmental object, then it will scatter the signal, and then that particular portion that will reach to the okay, receiver there. So that again to be defined, what will be the clutter and all. Okay, so we need to remove that clutter, and that clutter is nothing but a that to be considered as a noise. So we supposed to remove that a noise at the receiver there. But in the case of a pulse radar, okay, in a CW radar, continuous signal is transmitted. But in the case of a pulse radar, there is no need of a isolation because in a pulse radar, what happened? We supposed to send a signal. Okay, this is about your pulse radar. Okay, we are supposed to send a pulse of a same duration, but there will be a difference in what transmitting pulse. Okay, one pulse and another pulse. Suppose this pulse one and a pulse two. So in a pulse radar, what happens when we are transmitting a pulse? When we are transmitting a pulse one, so in that case, your receiver will be switched off. Okay, at the type of a transmission, receiver will be switched off, and when that pulse send, okay, that is about the end of the pulse at this particular, so receiver is on, and then within this particular period of a time, okay, within this particular period of a time, we supposed to receive the signal, okay, in this particular distance, okay, in this particular whatever the pulse repetition time, so we supposed to receive the signal from the a device. Okay, so that's why there won't be any echo, or we can say that okay, that sorry, there won't be any requirement of isolation when we are using a pulse radar because a transmitter is off. Sorry, transmitter is on, but receiver is off. So receiver will not damage because at the time of a transmitting pulse, receiver is off. When that pulse sends, then receiver is on. Then your receiver will receive the echo signal. Okay, so that's why we supposed to consider that a pulse radar. So instead of a ACW radar. But every devices they have some limitations, whether it is a pulse radar or a CW radar, and that limitations regarding the what will be the noise and all. Okay, or that target within this particular range. Okay, the target is to be within this particular time. Means your echo signal is to be reached before sending the second pulse. Okay, that's why the limitations for this pulse radar. For the continuous radar, there are the limitations for what keep the isolation at this particular place. So to avoid this isolation, okay, to avoid that transmitted signal reach to the detector and detector damage, to avoid this, so isolation is used. We can use a various kinds of device, circulator. Okay, we can use junctions there, or another way we can use a different kind of a polarization. Okay, That's what we can say that a hybrid polarization. So that the isolation, okay, amongst this transmitter and receiver will be happen. Okay. Or we can say that your receiver will not damage because of that it transmitted. So this can be the way for the isolation in ACW radar. So there are the various again another ways there we say that continuous signal we are transmitting. So we are a various way instead of sending the continuous signal, we supposed to say that variation in the amplitude or a variation in the phase. And when we are transmitting the signal with a variation in the amplitude or variation in the phase, so at the receiver, we are getting at this particular receiver, we are getting the a sideband. If it is a fixed one, so no sideband. If there is a variation in the amplitude or a phase, so at the receiver, we supposed to get the various sidebands. Okay, so at this Doppler filter. So that's why we supposed to consider that it transmitter and receiver, whether the transmitter and receiver is AM modulated or a FM modulated. If it is AM modulated, then we supposed to remove the whatever the noise. Okay, so then that case that AM sideband have some particular level of carriers and all. Okay, so we have the carrier. We supposed to say this one is about a carrier. So these are nothing but a sideband. That carrier signal has some particular level. If we are supposed to consider that a AM or a FM. So we consider that a use of a AM or a FM, and that will be used to avoid the a signal, okay, reflected signal reach to the a transmitter, or that will be remove the a noise also. Okay, so that particular will be used to remove the a noise because the transmitter noise that will be reached at this receiver there because that noise is nothing but what? Not only the echo signal. Okay, not only the echo signal. That a noise is nothing but the echo signal received from the clutter. Okay, so we can say that a transmitted clutter in that case. So clutter means what? A object. Okay, any object that will be nearby to the transmitter. So that will be received at this a receiver there. Okay, that's why we can say that a transmitter. And that transmitter clutter, it has the same frequency. Okay, transmitter cluster because it is a nearby signal. Okay, it that echo signal received here at the receiver that will be come from the nearby object. Okay, but it has the same frequency. Okay, because we are either rotating the transmitter and receiver section or we say that this one is in motion. Okay, so we have the scope here. Okay, either moving this one. In that case, we supposed to we get the Doppler shift, add the Doppler filter because of the transmitter filter also. So to avoid it, instead of using a small noise or a small section of a transmitted signal at the receiver, we supposed to use a intermediate filter instead of directly the mixer. We supposed to use a intermediate frequency receiver IF. Okay, at this mixer stage there. After this mixer stage, so we will get exactly the whatever the signal received at this particular Doppler. Okay, so we draw the diagram here at the transmitter and receiver because you are transmitting and receiving again a same here. Only the portion here. So what we supposed to consider? We have the a mixer. Okay, so we have the mixer because the transmitting signal frequency. We supposed to say that what is about your object here. Will not say your object right now. Okay, so object because we use a separate antenna for this and a separate IF for this. Okay, so then we have the transmitter, then we have the detector here, okay, EW transmitter, then we have mixer here, and we're supposed to use a oscillator here. Okay, we need to use a oscillator to identify that what will be the sideband. Okay, that's why we're supposed to consider that a oscillator here. What is about the oscillator we're supposed to use here? And that oscillator frequency, we consider that F. This one is about a transmitting signal frequency. Say here F1 now. Okay, that F4 signal is transmitted. The about F4 is transmitted by this transmitting antenna. Okay, this is for the antenna we say. Okay, this one is about your antenna, and that antenna is called as a transmitting antenna. Then we use a sideband filter. One is about a sideband filter we supposed to use here, and then we use here a receiver mixer. Okay, this one is about your mixer, sideband filter, then a receiver mixer. At the receiver, we are getting the signal to this receiving antenna. This one is about a receiving antenna. We are getting the signal that is about F2 plus F3 plus or minus FD here. And at a receiver mixer, we are supposed to get here F4 plus or this one, F5. So we can say that we have the signal here F4. We have the signal F4 plus FIT. Again, we have the signal F4 minus FIT. Okay. And here we are getting the signal that is about F4 plus FIT. Then when it reaches to the receiver here, okay, when it reaches to the receiver there, so we are getting the signal here at this particular stage. That is about FOF get cancelled, only FD, FD and FIT will receive. Here we are supposed to use the IF here, IF amplifier. Then we have second detector. Okay, this one is about a second detector. Then we consider that a Doppler amplifier or a filter. Okay, filter amplifier. Okay, so this one is about a Doppler amplifier, and then we say that there will be the indicator. Say that this one is about a indicator. So now at this case here, at this place we are getting the signal that is about what? We say that FIT plus or minus FT. That is about FIT here. Okay, plus or minus FT. And that is useful here to identify that what will be the exactly AFD. Okay, what will be the exact value of the this Doppler shift here. So that's why we consider here. Okay, that's why we consider here the IF amplifier and the super sideband filter. Okay, we supposed to introduce all these here at the receiver side, and that will give us the exactly what is the FD. After this one IF amplifier, we supposed to get a FD here. So again, a second detector we are that will exactly identify what will be the FD here. Okay, that will be exactly identify what is the FD here. So this one is about a block diagram of a CW radar. Okay, with a IF receiver, and that receiver section is supposed to called as a super heterodyne receiver here in this case. So somewhere we say that a IF earlier case IF is not used. Now here we have the IF here. Okay, and then this one is useful for the identifying that what will be the FD here, and through that the receiver sensitivity using this IF will be improved here. Okay, so how to improve the receiver sensitivity means we say that there is a noise and everything. That's why we supposed to add a local oscillator that will be for the reference purpose here. Okay, so this one is about the section of a receiver. Now this particular section, if you consider that it has the transmitter. Okay, so we have the oscillator here, we have the mixer here, and then at this particular receiver section, so we consider that whatever the signal we have received at this, that that will be contain that signal contains some noise, but that noise can be removed using this IF and all. And here we are supposed to use a separate transmitter and receiver section for this. So that's why so isolation among this transmitter and receiver will be takes place, but only it will add a additional component. Okay, it will add a additional component in this circuit there. And again we supposed to use if whatever the a filter, okay, whatever the filter here, that is to be used only for understanding the what will be the reference signal there, because a filter select a one of the sidebands as a reference signal. That's why it will improve the sensitivity, because we say that FO plus FD or FO minus FD. Okay, FO plus FD or FO minus FD. So what will be the where will be the plus or minus sign? How to identify that a plus sign and a minus sign? Okay, so to identify that plus and minus sign, so we supposed to use a sideband super heterodyne receiver. Okay, sideband super heterodyne receiver. Okay, this one. So that's why we have a second detector. Just we say consider. So that we'll get the exactly the FD, whether it will be a plus FD or a minus FD. So we are getting through this. Okay, so that is the role of your CW radar, which has a IF receiver, and that's why, or we can say that the sideband IF receiver here, and that sideband IF receiver that will provide you the what will be the plus FD or a minus FD. Otherwise, a band of the filter is to be a large, a lowest cutoff frequency and a highest cutoff frequency for the same. So instead of that, we supposed to use this particular IF filter and a second detector to identify that what will be the FD here. Okay, so with this, we stop here. We'll continue the same again in the next lecture for their applications of CW radar and for what purpose this CW radar to be used. Okay, so again we can use instead of a single filter here. Okay, after that detector and a filter here. Okay, so that's why we consider that after IF amplifier, we can use a multiple filter band so that that will identify that what will be the FD exactly within particular range. AFD will be there. So that will remove the noise here, and that will be used to operate your receiver for the wideband operation. Okay, this again instead of that single filter, we can use a multiple filter, and that will improve the bandwidth there. Okay, or that will improve the frequency response characteristics of this Doppler there. Okay, just like Doppler is. So with this, we stop here. So thank you all of you.